Welcome to NALLA NARASIMHA REDDY Education Society's group of institutions, integrated campus, Hyderabad, structural engineering, reinforcement concrete. I am Dr. Imesh Babu, Professor, Department of Civil Engineering. Unit 5. In this unit, I explained about different type of footings and explained design of wall footings and this is isolated footings. Regarding isolated footings, I explained regarding critical sections. That is, if you see this one different critical section column, this is footing slab or stepped footing or sloped footing slabs. This is, I explained, this is very important to understand this figure. This one you try to understand. See, one is IS per IS for size 6. Yeah, now this is the, if you see here from the face, this is very critical section for bending moment from this edge to this edge. Now this distance is here, if you see, that is D. That is small d is effective depth. What is effective depth? You know, from the top to center of your reinforcement, right? See here, if you see, and here if you see this one here, this is the critical section for this one. What? For one-way shear. For two-way shear, here, what is that? If you see here, this is ABC, it's a critical section, right? Now, if you see, now there are three important points in isolated footing designs. Okay, in examination, previous examination, they asked to explain the procedure. Then you have to write all these details, right? Now, section 1, at column or pedestal, whatever it may be, but we'll see in only columns. So to compute maximum bending moment, this section 1, this is from the face of the column. This will act as your one-way. This is inverted cantilever slab, right? See, and if you see from here to here, what is that? This is one-way shear critical depth. That is at a distance of D, effective depth. And if you see, this is ABCD, that is punching shear. Whenever a thin paper is there, if you put like pencil or like that, what will happen? It will break down. That is assumed at D by 2. That is ABCD here. All around the column, whatever it may be, that is square, rectangular, or circular, the distance is D by 2, and that is, if you see, that is critical section punching shear. Here we have to three critical sections. One we have to design for bending moment, and we have to design for one-way shear, and we have to design for check for two-way shear. Okay, here very important. That is, these are three important critical points where we have studied from this IS 456, and this you must explain in detail in the examination. Compulsory, you will get one question, design of isolated footing, either maybe in numerical values or explain the procedure. Okay. Now, what is the minimum thickness of footing is IS for 3.14 slab, and this is 150 mm, 34.12. This from the class. Okay. Here I explain 34.12 slab. Okay, this is minimum edge thickness is 150 mm, and for piles 300 mm. Okay, isolated footing. What is isolated footing? Individual footing. There are different type of isolated footings. I explained square footing. It may be rectangular or circular footing. Yeah, whatever may the shape. Okay. There may be two types of again footings, that is the flat footings and sloped footing. Whenever thickness is more than 1.5, 150 mm at the edge, if you go for design of that is a sloped footing, you can save some concrete and cement. So This is a sloped footing, right? Otherwise, generally you can go for flat footing. That is depend upon your financial situation. If you want economical, you can reduce. Suppose it is minimum 150 and whatever thickness you will get at this edge, you have to take this much. Suppose 300 400 like that. So you can design accordingly, according to pending moment, you can design reinforcement. This is the important point in this one, right? So this is isolated footing, and we'll see what are the design consideration. Now, the design is of footing is include the following very important points. One is the depth of the footing, right? One is the depth of the footing. Second one is to calculate reinforcement and check on serviceability. Serviceability condition we have to check, and check serviceability condition. These are three very important points. First one is we'll calculate depth of footing from the bending moment, and we'll calculate from the bending moment shear reinforcement, and we'll check for one-way shear, two-way shear for serviceable conditions. Say this is a example, one room, it may be multiple storied, number of rooms. Whenever gravity load is applied on this one, this transfer to slabs, slab weight and gravity load, self weight of the beams and slabs transfer to the beams and that under columns. Okay, these are footings. So this is upward pressure from the footings, and this is the downward load. So like that, total load of the building structure, how many floors it may be, and number of floors, that is individually transferred to the column. Ultimately, it has to transfer to footings. That soil has to bearing that load, that is soil pressure. That for that one we have to design footing. This is very important point. And design consideration. What are the design consideration? As explained this, as in slabs, generally for high yield steel, the percentage here, if you see here, minimum is 0.15 for mild steel and 0.12% for high yield steel, right? Same way, this is in whole schools in footings also. And one more important point, as per IS 456 class, as explained 26.5.21 and 2, what is that? The diameter of reinforcing bar shall not exceed 1/8 of the total thickness of the slab, right? See, suppose thickness is 200 what is 1/8? That is 25 Yeah. See, you should not go for 32 Suppose 100 thickness slab, that is 12 only. You should not go for 16 So that is the meaning of this sentence. What is this design requirement? The diameter of the reinforcement bar should not exceed 1/8 of width of your slab thickness. This is very important points in design consideration. Yeah, what is the design consideration? The minimum thickness edge of the footing on the soil or rock should be 150 and top of piles should not be less than 300 Yeah, generally in rock bearing soils, minimum thickness is 150 and in for pile caps you will see that is 300 thickness. There are 2 points here. Just in our this unit, we will see columns isolated footing for 150 but you remember also that for piles 300 Now the column transfer the load from top the footing by bearing, and this loaded is limited to a compression. Direct compression is given by 33.4 class, that is 0.456 FCK, and given by IS 456 33.4. According to IS, depth required for anchorage. Anchorage means that hooks at the edge. LD is equal to pi is the diameter of the bar, Fs is the steel stress of the reinforcement by 4 by tau VD. The tau VD is bond stress is given in the table 16 or 17 of IS 456. That is, we have to calculate development length. This is the design, one of the design consideration, right? Now where if you see pi is diameter of the bar, Fs is the stress in bar, 2Vd is the design stress, bond stress for 20 concrete and Fe 415. What is the LD? Suppose we say pi 0.87 multiplied by 415, 4 multiplied by 2.4. How you will take this is you can take from 25.21. Here, if you see this table, yeah, come to this 25. Yeah, this is 26.21. This is bond stress. From this one for M21.2. This is for deform for these values. Increase by 6% and for compression 25%. You must remember this is very important point here. You remember the table is given for tension plain bars that is mild steel bars. Now suppose if you consider for if you go for high yield steel, that is Fe 415, that is this bond stress will increase by 60%, and this tension will increase in compression is increased by 25%. See, this is very important point regarding in bond stress. Okay, this is given, and this is usually will take that is 40 by pi. Okay, now when the depth is required for the about development land, suppose you will can do development is required, you can turn as a U or L shape. So this we have to verify whether that length development length is sufficient or not in the footing. That is very important. It is more economical to adopt stepped or sloped footings. Okay, when this is within the limit, you can go for stepped footing or sloped footing. That way, it is as I explained, because one footing will take nearly 8 to 10 bags of cement. If you go for sloped footing, it reduced at least 2 or 3 bags. Overall, it will save to you. So this is one of the design consideration. Okay, I will explain this show in the next video. Thank you. Thank you all. I will end the session and will explain this show in the coming video. Thank you.